Welcome friends, welcome to the training of electrical interlocking systems, especially for the battery energy storage systems substations. So in this training we will learn together that we will take one feeder, which is a 220 kV feeder, and that's feeding to a BESS substation. So you can see here in the background, if you see in the picture here, this is the substation here, and you can see these are the containers, these are the units where the BESS battery energy storage systems are installed. So we will go through and learn these things. So uh, first I would like to explain about myself that I am a professional electrical engineer, and I have now almost 23 years of experience, and I have served in different companies and different voltage levels, in consultancy, in substation, in the design, everywhere. So I have worked more than now 100 substations, and I have been involved in designing, commissioning and consultancy services for these substations. So I have had this own experience as well, so that will be beneficial for you to learn these things. So in this training we will start with the very basics, that what equipments are installed in the substations, and why we are using these substations, these equipments, different type of equipments. Okay, so major focus will be related to the controlling equipments, the primary equipments like isolator, breaker, switches. So we will focus on these, and then we will see the requirement of interlocking. So what is interlocking, why we need interlocking in substation, and we will just go through a simple some types of interlocking. Then we will see the on-load and off-load operations, what are these, and which equipment can perform off-load operations, which equipment you can use also to perform on-load operations. Next we will study and we will learn about the electrical and the mechanical interlocking. So what are these? Next we will see the another interlocking system that's been used mostly in Europe and in the ancient time, in the start of the electrical systems. The another interlocking system is the key castle interlocking system. So we will see how it works. We will not go in detail in deep on these topics, but I will just give you a brief introduction and understanding how the systems works. Then we will see the auxiliary contacts, rotary mechanism, and what is the function of these rotary mechanisms in the substation, and how we are using these rotary mechanism and the rotary contact or auxiliary contacts in our interlocking mechanism. So we will also learn here that what are the NO and NC contacts. Simply you can call these are normally open and normally closed contacts. Another aspect, now as the system is being developed and improved, we are now moving towards the more electronic and microprocessor based systems. So the new interlocking now is sometimes taking place in the bay control units. So we will see what is the bay control units and we will see the very basics, that how it works and how the soft logic is being developed inside nowadays in the bay control units. So we will see the soft logic interlocking versus hard logic interlocking, and how these are being used in the substation these days, and how it is being implemented as per my experience. We will also learn about very basics about the new substation protocol, which is an IC 16850. So I have commissioned in the start in the Middle East some substation that were starting or based on this protocol IC 16850, and also I got the training from Europe, that you can then I will give a brief introduction about, because this is again a vast topic, so I will give you the thing that's related to the interlocks. So then we will see the horizontal and vertical communication. What does it mean in the substation automation systems? Then we will see the another topic, which is a goose. What is a goose, and how the goose is used for the interlocking nowadays in the substation. Next we will learn about the lockout relay, which is in 86 is the NC code for this, and we will see what's the role of lockout relay in the substation. Again, the lockout relays are nowadays are the hardware based and also the software based lockout relays as well. Then lockout is created through soft logic, or it's sometime it's on a function, built-in function inside the relay. So we are, instead of using a separate lockout relay, we are using lockout through soft logic. So we'll go through these and then we'll see the interlocking requirement from the remote end. So for example, if you have a remote end substation and you want to close the isolator or the breaker or earth switch, what are the interlocks, what is my experience and how these are being achieved. For example, the remote interlocks can be achieved through conventional SCADA, or using a mirror bits or bits, which is a direct communication between one relay to the another relay through the line differential relay, or through SDS, through SCADA, or through SAS systems. So next thing is the understanding of the BESS feeder. So we will open a complete one 220 kV battery energy storage system feeder, and we will see different interlocks being implemented in this way. So uh, this training is designed from basics to the end, and the concept is that I will give you a brief overview of all these topics, plus I will at the end will discuss in detail about the interlocking arrangement of our 220 kV battery energy storage system. So we know that battery energy storage systems are now more and more common. So but this interlock will be covering from the substation end. One end is connected to the BESS, another end is connected to the substation. For example, if you see this picture, so we were dealing the all interlocks are implemented here that's related to this BESS. So we will learn about the interlocks at this level, at the highest voltage level. So this training, after completing this training, you will have a good idea. You will also get this interlock logic diagram that's being formed using NO NC contacts, and you can polish your skills, and you will be able to get a good idea about the how substation interlocks works. So I will encourage everyone to join this training. Thank you very much.